So cumulative distribution will also be covered. Cumulative distribution will also be covered. One small definition only. So this is problem number 3. Move down. Note this problem. Let x1 and x2 be independent normal random variables with means mu1 and mu2 and the standard deviations. 1 minute. And the standard deviations sigma 1 and sigma 2 respectively, and the standard deviation sigma 1 and sigma 2 respectively. Don't raise hands right from the beginning. Raising hands, don't. And standard deviation sigma 1 and sigma 2 respectively. Consider y is equal to x1 minus x2 and means of x1 and x2 are same. Good morning to everybody. Means of x1 and x2 are same. That is mu1 is equal to mu2 is equal to 1. Sigma 1 is 1. Sigma 2 is 1. So as we discussed already, write the options or take the screenshot. Write the options or take the screenshot. Remember, yesterday we have discussed, suppose x1 and x2. Good. Remember, yesterday we discussed if x1 and x2 are independent normal random variables, then its linear combination c1x1 plus c2x2 is also a normal random variable. So here y is equal to c1, here c1x1, here c2, c2x2, c1x1 plus c2x2, c1 value 1, c2 plus c2x2, c2 value minus 1. So c1x1 plus c2x2 is also a normal random variable. Therefore, correct answer is either option A or option D, because options C, option A or option B. Because options C and D, they did not mention, they mentioned they are not normally distributed. But we discussed already in the last class, if x1 and x2 are independent normal random variables, its linear combination c1x1 plus c2x2 is also a normal random variable. But options C and D, they are saying they are not normally random variables, not normal random variables. So C and D eliminated. Moreover, they mentioned the correct answer is either option A or option B. But both options A and B, they said mean 0. Both options A and B, they said mean 0. So you need to find only variance. You need to find only variance of y. That's it. You'll get clarity. Variance of y is 1, option A correct. Variance of y is 5, option B correct. You'll see. But anyhow, I'll be teaching mean also. I'm teaching mean also. Given y is equal to x1 minus x2, here mean of y. Mean of y means e of x1 minus x2. E of x1 minus x2. E of x1 minus x2 is e of x1 minus e of x2. E of x means mean. E of x1 means mean of x1. E of x2 means mean. E of x1 means mean of x1. So let it be mu1. E of x2 means mean of x2. Let it be mu2. So mu1 minus mu2 is 1 minus 1, 0. So mean of y is 0. So you just need to calculate only variance of y. Let us calculate variance of y also. So first of all, in the last class, I have already given this formula, variance of ax plus b or ax minus b. In both the cases, I gave this formula, a square into variance of x variance of ax plus by or ax minus by is equal to a square into variance of x plus b square into variance of y. But it is valid only when x and y are independent random variables. So therefore, here we need to find variance of y. Y means x1 minus x2. I will go to the next slide. Next slide, calculate variance of y. So variance of y is equal to variance of x1 minus x2. Variance of x1 minus x2. So variance of ax, a means 1 plus by plus b means minus 1. Ax plus by, a means 1, b means minus 1. So that is a square into variance of x plus b square, b means minus 1, b square into variance of y. Already given the formula. In place of a, 1 is there. In place of b, minus 1 is there. So 1 square is 1. Variance of x1 is sigma 1 square. Variance of variance of x2 is sigma 2 square. Variance of x1 is sigma 1 square. What is sigma 1 square value we were given? We were given variance of, look there. So sigma 1 is 1, sigma 2 is 2. Sigma 1 is 1, sigma 2 is 2. So 1 square plus 2 square, that is 5. Therefore, option A correct. Option B correct. Mean 0, variance 5, option B correct. But they are normally distributed. Right there. Therefore, y is equal to x1 minus x2 is normally distributed with mean 0 and variance 5. Next slide. Next slide. Problem number 4. Let capital X be a random variable following normal distribution with mean 1 and variance 4. Let y be another random variable with mean -1 and variance unknown. If p of x less than or equal to -1 is equal to p of y greater than or equal to 2, comma, the standard deviation of y is option A 3, option B 2, option C √2, option D 1. So this problem given on the gate, Computer Science Engineering 2008. So x is a normal random variable. Here x is a normal random variable. X is a normal random variable with mean 1. First mean with mean 1. Here mean 1. Variance 4. Variance 4. Variance 4. And y is another normal random variable with mean -1. And variance means sigma square, and variance is unknown. So this is the mean of x. This is the variance of x. So this is the mean of y. This is the mean of x, this is the mean of y, and this is the variance of y, and this is the variance of x. Mean of x, variance of x, mean of y, variance of y. Next slide. Going to the next slide. Next slide. So first you write what you are given. You are given p of x less than or equal to -1 is equal to p of y greater than or equal to 2. So to solve any problem regarding normal distribution, please convert the random variable x into standard normal random variable z. Any random variable x should be converted to standardized normal random variable by making x as x minus mu by sigma. X minus mu by sigma is denoted by z and called as standard normal random variable. X minus mu by sigma called as z, called as standard normal random variable. So here make x as x minus mu by sigma. That's why first add minus mu both sides. Next divide both sides by sigma. Next, add minus mu both sides. Divide both sides by sigma. So here x minus mu by sigma is called standard normal random variable denoted by z. Minus 1 minus mu. Mu means mean of x. Mu means mean of x, that is 1. That is 1. And divided by sigma. Sigma means standard deviation of x. Here variance of x is 4. Variance of x is 4. Therefore sigma x is 2. Sigma x is 2. Left side x information, right side y information. So x minus mu by sigma is denoted by z. Only variable has been changed. Only variable has been changed. So this is also x minus mu by sigma only. So that is z. Greater than or equal to, here this mu means mean of y. Mean of y. Right side y information. Mean of y is minus 1. So 2 minus of minus 1. That is plus 1 by sigma. So P of z less than or equal to minus 1 is equal to P of z greater than or equal to 3 by sigma. So remember everyone, this property I will explain just now only. First note down this. After completion of this problem, I will explain this property. And everyone, note down this property. P of z, z less than or equal to minus z naught is equal to P of z greater than or equal to z1. Then z naught is equal to z1. Then z naught is equal to z1. So remember, if P of z less than or equal to minus z naught, I will prove that result. Just wait for 1 minute, I will prove that result. This is minus z naught. This is z1. So P of z less than or equal to minus z naught is equal to P of z greater than or equal to z1. So according to that formula, z naught is equal to z1. Minus z naught is equal to minus 1. Minus z naught is equal to minus 1. So z naught is 1. So z naught is 1. Minus z naught is equal to minus 1. So z naught is 1. So from this 3 by sigma. So therefore sigma is equal to 3. Therefore standard deviation of y is 3. So I will prove this result just now only. Both will be same. Yes, both will be same. That's why I have written. I will prove this result. Both will be same. Both will be same. If you have a doubt, look here, all of you. Just 1 minute. I will prove this result. 1 minute only it will take. P of z less than or equal to minus z naught is equal to P of z greater than or equal to z1. Look the diagram, everybody. So this is z is equal to z. This is left side, we must have minus z naught. Left side we have minus z naught. Right side we have z1. Right side we have z1. So here you observe it correctly. And observe that correctly. Here z less than or equal to minus z naught. Less than or equal to minus z naught means area to the left side of minus z naught. Area to the left side of minus z naught. Z greater than or equal to z1. Greater than or equal to z1 means area to the right side of z1. This is area to the right side of z1. This is area to the left side of z0. Now let us write. Look here. I want this red colored area. Red colored area I can write like this. 0.5. Red colored area is equal to total area to the left side is 0.5. From this 0.5 area, if I subtract area between minus z0 and 0, we will get red colored shaded area. Similarly, green color shaded area is total area to the right side of origin z is total area to the right side of z1 to the right side of z is equal to 0 is 0.5. From this 0.5 area, if I subtract the blank area, means white color area that lies between z is equal to 0 and z is equal to z1, we can get the shaded area. Z is equal to z1. Z is equal to z1. We can get the shaded area. So this 0.5, 0.5 cancel. So here minus symbol, this minus symbol cancel. Still we have probability of minus z0 less than or equal to z less than or equal to 0 is equal to probability of 0 less than or equal to z less than or equal to z1. Do you know normal distribution curve is a symmetrical curve. Symmetrical curve means interval length same, area same. So whatever the area that lies between minus z0 and 0, yes, this property, man, I have to see. This is z less than minus z naught. This is minus z naught. Z less than minus z naught means what? Area to the left side of minus z naught. See, again you are asking the main concept of the problem only. So total area to the left side of origin is 0.5. Total area to the right side of origin is 0.5. From this 0.5 area, total area to the left side of z is equal to 0 is 0.5. From this 0.5 area, if I subtract this blank area, we get red colored area. So 0.5 area minus blank area that lies between minus z0 and 0 is equal to, similarly this green colored shaded area, total area to the right side is 0.5. From this 0.5 area, if I subtract this blank area, we'll get this same thing I have written. Blank area lies between z is equal to 0 and z is equal to z1. Here blank area minus z0 and 0. And according to the symmetry property, the area that lies between minus z0 and 0, concentrate what I am saying. According to the symmetry property, the area that lies between minus z0 and 0 is same as that of the area that lies between 0 and z0. Because of symmetry, what I said, because of symmetry, the area that lies between minus z naught and 0 is the same as that of what, man? Who said independent random variables? This property, is there any rule? I did not use independent property here. Why you are raising the doubts? Where did I say independent property? Yes, corresponding to two different random variables, no issue. Yes, here x and y two different random variables, no issue. So what is the property? X and y two independent random variables, no issue. So here 0, here 0, here z0, here z1. So z0 is equal to z1. Your doubt is therefore z0 is equal to z1. Why z must be 0? That is wrong. And moreover, z minus z0. Yes, here z, two jets corresponding to not only 1z, 2z, 3z, n number of variables also will be represented in the single normal distribution table only. And Muralidhar Reddy, there are two independent random variables. I did not say two independent random variables. In this problem also, no two independent random variables. Two random variables, but you are plotting. Yes, n number of variables also, plotting graph is same. We should not draw the different graph. So why you are worrying? Here, conversion is always single random variable only. Random variables may be different. N number of random variables also, if you can make, please don't raise the hand. N number of random variables also, when you convert them into standardized normal random variable, you are still getting confused. X is one variable, Y is one variable. Look here, X one variable, Y one variable. So X minus mu by sigma, it becomes Z. Here y minus mu by sigma, it becomes z. Both belong to same normal distribution graph only. For this random variable, you should not draw one graph, and for this random variable, you should not draw another graph. So not only two random variables, three random variables, four random variables, n random variables, it will be converted to standardized one normal random variable only. Because any random variable minus mu by sigma is a single standard normal random variable. Plots will not be different. Even see, this is another random variable is t minus mu by sigma. For this also z only. Any random variable minus mu by sigma will become a standard normal random variable, that is one graph only. And note down this and try yourself. Note. Note. Listen to me. Whenever mean and variance of the normal distribution are not given, then mean and variance of binomial distribution should be used. Mean and variance of binomial distribution should be used, but it has to satisfy two conditions. Condition number one, number of trials very large, means n tends to infinity. Theoretically n tends to infinity, practically n should not be infinite. Practically n is large, means 50 also large only, 1000, 100. Next, p value should not be nearer to 0, or q value should not be nearer to 0. P value should not be nearer to 0 and q value should not be nearer to 0. Then only mean and variance of binomial distribution should also be converted as mean and variance of normal distribution. Remember, any random variable minus mu divided by sigma is a single one type of standard normal distribution only. Graphs will not be different. I know. If the mean and variance of variance 4 in the last question. I agree with you. I don't know if the mean and variance of binomial distribution mean and variance of normal distribution, sorry, if the mean and variance of normal distribution are not given, then mean and variance of binomial distribution should be used if number of trials are very large. Next, neither P nor Q is very small. Neither P nor Q is very small means P value should not be nearer to 0 and Q value should not be nearer to 0. P value should not be nearer to 0 and Q value should not be nearer to 0. Sometimes one of them may be 0, no issue. Write down this problem. Assume that 4% of the population over 65 years old has over 65 years old has Alzheimer's disease. Alzheimer's disease means memory loss disease. If a random sample of 3,500 people. If a random sample of 3,500 people over 65 years is taken, then the probability that fewer than 150 of them have the disease is dash. Next line. Area under normal curve between z is equal to 0 and z is equal to 0.86 is 0.3051. Next slide. So, percentage of people having memory loss disease is 4%. Among all people, a random sample of 3,500 people were selected to confirm whether they have memory loss disease or not. Among them, 4% of the people having Alzheimer's disease. So number of selected people, 3,500. Percentage of people having Alzheimer's disease is 4%. 4% means 0.04. Q means what? 1 minus P. That is 0.96. But what I said, whenever the mean of the normal distribution is not given, mean and variance of the normal distribution are not given, then mean and variance of binomial distribution should be used as mean and variance of normal distribution if number of trials n must be infinity. N tends to infinity theoretically. Practically, n is a big number. N is a big number means even 50 also big number only practically. 50, 100, 1000, so on. Here n value 3,500. So mean of the normal distribution is not given. So mean of the normal distribution is calculated from mean of the binomial distribution. Mean of the binomial distribution. Binomial distribution mean NP. Now this is equal to 3,500 multiplied by 0.04. Is it 140? I think 140. Next, variance of the normal distribution is equal to variance of the binomial distribution. That is 3,500 0.04 into Q, that is 0.96. What is the answer? Then from this we need sigma also. 134.5. 134.5. What is sigma value? 11.59. Yes, this is correct. 11.59 is correct. 11.59. Sigma is equal to 11.59. Just for the sake of our convenience, you are asked to find the probability that fewer than 150 people having Alzheimer's disease means less than 150 people having Alzheimer's disease. So assume X is equal to number of people, assume X is equal to number of people have Alzheimer's disease, because you are asked to find the probability that less than 150 people having Alzheimer's disease. So that's why assume, see, small means 0.001, minimum 2 decimal places, anonymous attendee, small means in probability and statistics, small means minimum 2 decimal places will be 0, like 0.001, 0.002, 0.003, then only it is taken as small, otherwise it is not. Number of people having Alzheimer's disease, you are asked to find the probability of less than 150 people having Alzheimer's disease. You are asked to find the probability of less than 150 people having Alzheimer's disease. To solve any problem regarding normal distribution, make X as Z. To make X is only normal random variable. Z is a standard normal random variable. To solve any problem regarding normal distribution, you need to convert your random variable into standardized normal random variable. To make X as a standardized normal random variable, make X as X minus mu by sigma. To make X as X minus mu by sigma, add minus mu both sides. Add minus mu both sides. Next, divide both sides by sigma. So X minus mu by sigma will be Z. 150 minus mu, that is 140 by 11.59. I think after simplification, it should be Z less than or equal to 0.86, I think. 0.8051. Yes, answer correct. Answer correct. 0.8051 is correct. This is 0.862. Correct. 0.862 is correct. Now draw the diagram. Here itself I am drawing the diagram. Look. This is the normal distribution diagram. Standard normal distribution diagram. This is Z is equal to 0. Z is equal to 0. 0. Neither nor means p value should not be nearer to 0 and q value should not be nearer to 0. Okay, no issue. And look here, 0.86. This is 0.86. Sorry, 0.86 will be on the right side of origin. So this is 0.86. Z less than 0.86 means area to the left side of 0.86. area to the left side of 0.86. This is the shaded area. Now the shaded area is area between the shaded area, I can write like this, that is equal to area to the left side of origin is 0.5. Area to the left side of origin is 0.5 plus we just need area between z is equal to 0 and z is equal to 0.86. Area between, we just need area between z is equal to 0 and z is equal to 0.86. So this is 0.5, and in the statement of the problem we were already given area under the normal distribution between z is equal to 0 and z is equal to 0.86 is 0.3051. So answer 0.8051. In any competitive examination, not only GATE, everywhere area under the normal curve between 2 points must be given. But except properties means area under the curve between z is equal to 0 and between -1 and 1, between -2 and 2, between -3 and 3 will not be given. Other than that, anything is required will be mentioned in the exam. Just note this and try yourself. Write down. If the variable z has standard normal distribution, you need not convert into standard normal distribution. They have already mentioned z is a standard normal distribution in this problem. So no need to convert, already given. And P of 0 less than or equal to z less than or equal to 1 is equal to 0.34. Then P of z square greater than or equal to 1 is equal to dash. Try yourself. Answer should be 0.32. Next slide. Right on. Next slide. Median and mode I will teach in statistics. Uniform distribution or, write down, uniform distribution or rectangular distribution. Write down. The probability density function of a, otherwise write like this, a random variable capital X is said to have a uniform distribution if its probability density function is given by a uniform distribution means a random variable, that is a random variable is said to be uniformly distributed in certain interval AB if its probability density function is 1 by B minus A. Actually, the application of uniform distribution is the probability of occurrence of an event in each and every interval is same. The probability of occurrence of an event in each and every interval is same. For example, for every 1 hour, 2 trains will arrive at the station. For every 1 hour, 2 trains will arrive at the station right from morning 6 o'clock. That means what? Probability of arrival of trains at the station are uniformly distributed in the time interval of 1 hour. That 1 hour time interval is A less than X less than B. A is 6 o'clock, B is 7 o'clock. That means next to 7 to 8, again 2 trains will arrive at the station. And 8 to 9, again 2 trains will arrive at the station. That means the probability of arrival of trains at the station are uniformly distributed in the interval AB, whose probability density function is K. Probability is same probability. Probability of arrival of trains at the station are uniformly distributed in the interval AB. For every one interval, probability of arrival of trains is same. That same value, let it be K. That same value, let it be K in the interval A less than X less than B. We know that total probability, sum of the probabilities is equal to 1. We can write like this. Same probability means K, but problem is defined only from A to B. F of X is K dx is equal to 1. K into dx is X, A to B is equal to 1. So K into B minus A is equal to 1. So K is equal to 1 by B minus A. That same probability value B minus A. I don't note. Statistics, it is there in course. After this, we need to discuss. Next slide. Note. Write down. First point, mean E of x is equal to a plus b by 2 remember next variance b of x is equal to b minus a whole square by 12 standard deviation, that is b minus a by root 12. Next, e of x square. E of x square is a square plus ab plus b square. Yes, E of x. Now, E of x power r, that is b to the power of r plus 1 minus a to the power of r plus 1 by r plus 1 into b minus a. Remember, if you can remember the last formula, we can derive everything. If you take r is equal to 1, you will get first formula. If you take r is equal to 2, you will get fourth formula. If you take r is equal to 3, even we get e of x cube also. All can be derived from the definition. And listen to me everyone, in binomial distribution, n and p are called parameters. In any definition other than x, whatever you have, which are called parameters. Binomial distribution, we have n c x, p power x, q power n minus x. Remove x, still we have n p q. Q means 1 minus p. So we have only n and p. In binomial distribution, n and p are parameters. In Poisson distribution, we have only lambda. Lambda is parameter. In normal distribution, mu and sigma square are parameters. Mu and sigma square are parameters. In uniform distribution, a and b are called parameters. In uniform distribution, a and b are called parameters. Problems? Problem number 1. No doubt. Suppose capital Y is distributed uniformly the open interval one comma 6. The probability that the polynomial uniform distribution is important. In the gate also problems were given. The probability that the polynomial 3x square plus 6x into y plus 3y plus 6 has only real roots is rounded off to at the end of the topic. I will tell you the important topics. Yes, you can identify using the intervals, but in the examination they must mention it is a uniform distribution. Otherwise, you can identify from the interval. 99% will be given in the exam. This problem given GATE Computer Science Engineering 2019. Right now, what is the given quadratic equation? Given quadratic equation is, remember in this problem, y is the random variable. Three x square plus 6xy plus 3y plus 6 is equal to 0. This is just like ax square plus bx plus c is equal to 0. Look there, ax square, a means 3, bx, x coefficient is b, bx, x coefficient is b, c, 3y plus 6 is equal to 0. Remember all of you, b square minus 4ac greater than 0. Roots are real numbers and different numbers. b square minus 4ac is equal to 0. Roots are real numbers and repeated numbers. B square minus 4ac less than 0. Roots are real numbers as well as complex numbers if b square minus 4ac less than 0. So in this statement of the problem, they have clearly mentioned. Don't raise hands. Please enter in question and answers. Suppose in the statement of the problem, don't raise hands. In this statement of the problem, they have mentioned that flow will break. In the question and answers, you can mention, I will clarify your doubt. So b square minus 4ac greater than 0, roots are real numbers and different numbers. B square minus 4ac is equal to 0, roots are real numbers and repeated numbers. In this statement of the problem, they have clearly mentioned roots are real numbers, but they did not mention roots are real and repeated or roots are real and distinct. They did not mention. So that's why roots may be real and repeated or roots may be real and equal. They may be anything. Focus on what I'm teaching in the class. So here for real roots means they may be real and different, they may be real and equal. For real roots, b square minus 4ac greater than or equal to 0. B square means what? 6y whole square minus 4ac greater than or equal to 0. So 6y whole square. Next slide. 36y square. 4 3s are 12. 12 into 3y, 36y. 4 3s are 12 minus 12 into plus 6. So divide both sides of this equation by 36. So it is y square minus y minus 2 greater than or equal to 0. Also written as y plus 1 into y minus 2 greater than or equal to 0. So we need to find probability of 3x square. We have to find probability of 3x square plus 6x into y plus 3y plus 6. Answer 0.25. I'll check. Plus 6y plus 6. 3y plus 6, sorry. Has real roots. That means what? P of b square minus 4ac greater than or equal to 0. That is P of b square minus 4ac greater than or equal to 0 value. We have already found its value y plus 1 into y minus 2 greater than or equal to 0. B square minus 4ac greater than or equal to 0. Its value y plus 1 into y minus 2 greater than or equal to 0. I can write like this. This is also written as 1 minus p of y plus 1 into y minus 2 less than 0. P of a is equal to 1 minus p of a complement. A complement. A means y plus 1 into y minus 2 greater than or equal to 0. A complement means greater than or equal to 0, opposite meaning less than 0. That is what I am saying. B square minus 4ac greater than 0. Roots are real and different. B square minus 4ac is equal to 0. Roots are real and repeated. But in the statement of the problem, they have clearly mentioned roots are real. Real means they may be real and different, or they may be real and repeated. Which is correct, we don't know. That's why I have taken b square minus 4ac greater than or equal to 0. Meant for roots are real and real. That's it. They may be repeated, they may not be repeated. Continuation. If anybody doesn't know, please note down these values. If you don't know, all of you. X minus a into x minus b less than 0 is equal to a less than x less than b. Remember, by assuming a is the smaller value, x minus a into x minus b less than 0 is expressed as a less than x less than b. Remember, a is the smaller value. Roots of x minus a and x minus b, a and b. Roots are a and b, a less than x less than b, where a smaller, b bigger. Now, look here. In the previous example, 1 minus probability of what are the roots? Minus 1 and 2. In this example, roots are a and b. That's why a less than x less than b. Here, roots are minus 1 and 2. Roots are minus 1 and 2. So that's why I can write minus 1 less than y less than 2. And I'm going to do a small modification again. Be careful. Here roots are minus 1 and 2. So I have written minus 1 less than y less than 2. A small modification I am doing once again. Please listen to me and all of you read the question. All of you read the question. They mentioned already x value lies between. It is uniformly distributed random variable in the interval 1, 6. Uniformly distributed random variable in the interval 1, 6. So problem defined in the interval 1, 6. But in this problem, it is defined in the interval. I mean, in this step, we need probability from minus 1 to 2. Problem is defined in the interval 1 to 6 only, but actually we want probability from minus 1 to 2. So that's why problem defined 1 to 6. That's why minus 1 to 1 problem not defined. Minus 1 to 1 problem not defined. So that's why cut this interval. 1 minus probability of minus 1 to 1 not defined. So that's why not defined means 0. That's why I'm writing 1 less than y less than 2. 1 less than y less than 2. Actually, we need probability from -1 to 2. Problem not defined from -1 to 1. That's why cut the interval from -1 to 1. We just need probability from -1 to 2. Look there, all of you. Problem completed. Probability is equal to length of the shaded portion divided by length of the total interval. What is the length of the shaded portion? 2 minus 1 by what is the length of the total interval? 1 to 6 interval length, 6 minus 1. So this is 1 minus 1 by 5, that is 4 by 5, 0.8 is the answer. In this same manner, note this problem and try yourself. Next, problem number 2. This is the given question. This is the given question. (134) slide. Take the screenshot. 135 slide. 136 slide. 137. I am going to the next problem. I know if capital X is uniformly distributed random variable on the interval -5, 5, then the probability that the quadratic equation 100t square plus 20tx plus 2x plus 3 is equal to 0. Has complex solutions rounded off to 1 decimal place is answer 0.4. Here minus 1 to 2, but the problem is defined only from 1 to 6. But we need probability minus 1 to 2. So minus 1 to 1 problem not defined. That's why we need to take only from 1 to 2 because endpoint of the required interval is 2. Required problem. Try later. Problem number 3. A point you are asking again and again same story, man. Mr. Anonymous attendee. 1 less than y less than 2 means we just need area between 1 and 2. So area between 1 and 2. Length of the interval from 1 to 2 is 2 minus 1. Probability formula favorable cases by total cases. Favorable cases length of the shaded portion, that is 1 to 2, 2 minus 1. Total area, total cases means length of the total interval 1 to 6. Total interval length 1 to 6 is 6 minus 1 interval length. Suppose it is probability favorable cases by total cases. If it is length, favorable length by total length. Favorable length is length of the shaded portion. Total length is total length of the interval. A point is randomly selected with uniform probability in the xy plane. Within the rectangle with corners if capital P is the position vector of the point So, Ojasvi Jain, listen to me. Why you have not applied uniform random probability function in this case? It is what you are asking is 100% correct. 100% correct. Why I did not apply is, if you want, you can apply, no issue. But I have written the answer in easy manner. If you want, you can apply probability density function. If you want, you can apply P of 1 less than y less than 2. P of 1 less than y less than 2 means integral a to 2 integral a to f of y dy. So integral 1 to 2 f of y means what? Any random variable which is defined in the interval a comma b, its probability density function. Any random variable which is defined in the interval a comma b, its probability density function 1 by b minus a. 1 by b minus a. So here a comma b means 1 comma 6. A comma b means 1 comma 6. So interval 1 by b minus a. 1 by b minus a, 6 minus 1 into dy, 1 by 6 minus 1, that is 1 by 5 into integral 1 to 2. Simplify that, you will get the answer. If you want, you can apply, but actually I have applied easy technique. If you want to apply uniform probability function, you can apply. This is easy, that's why I have written directly. I am going to the next slide. First of all, draw the rectangle. Draw the rectangle. And everyone should be very, very careful. So this is 0, 0. Points I am writing. This is 1, 0. Next 1, 2. From exact 1, 2 means 1 unit right, 2 unit stop. This is 1, 2 point, 0, 2. These are the vertices of the rectangle. So this is x-axis, this is y-axis. If you want, you can use the definition, but it is lengthy. Without using the formula of the definition, we can answer directly. That's why. Moreover, you people don't know position vector. Position vector means in the statement, look there, one point is randomly selected with uniform probability inside the rectangle with these vertices. And capital P is the position vector of the point. Then the expected value of P square is, then the expected value of P square is 5 by 3, correct? This problem given in the GATE Computer Science Engineering 2004. GATE Computer Science Engineering 2004. Capital P is the length of the position vector. Position vector means vector passing through any point from the origin. Vector passing through any point from the origin is called position vector. Vector, it has to pass through any point from the origin. That is called position vector. Consider that any point as x comma y. Assume any point as x comma y. Do you know how to write a vector passing through 2 points? End point x coefficient minus initial point x coefficient into I means x minus 0 into I plus end point y coefficient minus initial point y coefficient into j bar. Right on. Let the position vector be position vector be. Position vector is represented by r bar. Position vector means end point Position vector means endpoint x coefficient minus initial point x coefficient into I bar. That is x minus 0 into I bar. That is simply xi bar. Next, endpoint y coefficient minus initial point y coefficient into j bar. That is y minus 0 into j bar. Now, length of the vector, capital P is the length of the vector, length of the position vector. Length of the position vector means magnitude of the position vector, means modulus of the position vector, that is x square plus y square. Capital P is the length of the position vector, that is modulus of the position vector. Now find P square. You are asked to find expected value of P square. Expected means E of P square. Is equal to E of x square plus y square, that is equal to E of x square plus E of y square. And all of you look at this formula. Did you remember this? E of x square formula I gave already. A square plus AB plus B square by 3. Or you can take R is equal to 2 in the last formula also. No issue. So here, and everyone listen to me carefully. To find E of x square, I am teaching technique only. I'm not using the formula. Technique of writing the answer easily. To find E of x square, x-axis x coordinates are assumed as A and B. To find E of x square, x-axis x coordinates are assumed as A and B. A and B. So E of x square formula, A square plus AB plus B square by 3. E of y square formula. To find E of y square, y-axis interval, y coordinates are assumed as A and B. To find E of y square, I am teaching very slow. To find E of x square formula, A square plus AB plus B square by 3. To find E of x square, x-axis intervals, x coordinates are assumed as A and B. That's it. Similarly, this A and B. To find E of y square, y-axis intervals, y coordinates are assumed as A and B. Y-axis interval, y coordinates are assumed as A and B. To find E of y square, y-axis intervals are 0, 0, 0, 2. Y-axis interval, y coordinates are assumed as A and B. Because to substitute in this formula. A square means 0 plus AB. A means 0, B means 2 plus B square by 3. This is 1 by 3 plus 4 by 3. So answer should be 5 by 3. Very good. Remember, to find E of x square, x-axis intervals are A and B. To find y of x square, y-axis intervals are A and B. Going to the next slide. Next slide. I don't. A box Muralidhar, what is the last step? This is E of x square plus E of y square. E of x square formula is this, but we don't know A and B. A and B are the interval values. To find E of x square, to know A and B, x-axis intervals 0, 0, 1, 0. To find E of x square, x-axis intervals assumed as A and B. A value 0 and B value 1. Substitute in this formula. Similarly, to find E of y square, same formula, only variable different. Formula same, variable different. E of y square also same formula. E of z square also same formula. To find E of y square, y-axis interval, y coordinates, y-axis interval 0, 0, 0, 2. Y-axis interval, y coordinates are A and B. Substitute them. Okay. Next, a box to be constructed so that its height is 10 inches and base is x inches by x inches by x inches. X by x inches. X inches by x inches. Stop. If capital X has a uniform distribution over the interval 2, 8, then is the then what is the expected value what is the expected value expected volume what is the expected volume of the box in cubic inches. Remember, a box we need to construct such that height of the box is 10 feet or 10 inches and base is a square base is a square base is x inches by x inches, one side is x inches, other side is x inches, but height of the box is 10 inches. Suppose capital X is uniformly distributed in the interval 2, 8, then what is the expected volume? So first of all, volume. By 3 not there, Sujana. I think only 840. 840 by 3 are correct. Please verify once again answer. 280 is correct. 280 is correct. Volume. Volume is equal to length into breadth into height. Here length is x, breadth is x, height is 10. Height is 10 inches. Length is x inches, breadth is x inches, height is 10 inches. So you are asked to find expected volume. You are asked to find expected volume. That is equal to E of 10x square. So 10 is constant, write it out, E of x square. Do you remember E of x square formula? E of x square formula, a square plus ab plus b square by 3. Here interval 2, 8. Because you don't know what is A, what is B. Whatever the interval given in the problem, that interval should be assumed as A and B. X is uniform distribution over the interval A and B. X is uniform distribution over the interval A comma B. Interval values are taken as A and B. Interval values are taken as A and B. So A2, B3. 280 correct. 2. Sujana, your answer is correct. And Madhavi, Soni, please verify the answer. Harsha, 280 is correct. Bhagwan, 280 is correct. So substitute there. Yes, Vivek arrow, 280 is the right answer then. Substitute. Going to the next slide. Yes, Lakshmi, Varaprasad. Yes, Ajay, correct. I am going to the next problem. So this is equal to 10 into a square. Yes, Himani Gaikwad. So what is the a value? 2, b value 8. A value 2, B value 8. Answer 280 cubic inches. Interval values always A and B. Interval values always assumed as A and B. So note down this problem and try yourself. Next. Write down. If capital X is uniformly distributed random variable over the interval 1, 4, the probability y less than or equal to 0, where y is equal to x square minus 4 is option A 3 by 4, option B 1 by 3, 2 by 3, 1 by 4. So problem number 5, this is, try yourself it later, 1 by 3 is correct. One more. If capital X has a uniform distribution then P of x plus 10 by x greater than or equal to 7 is try later 0.7. These two problems you can solve in the same manner, of first problem model. One more. Write down. Next slide. capital X is a random variable with a uniform probability density function in the interval -2, 10. In the interval -2, 10. Next, full stop. For y is equal to 2x minus 6, the conditional probability P of y less than or equal to 7 given x greater than or equal to 5, round of 2, three decimal places is dash. It was given GATE Electronics Engineering 2020. So start the solution. First of all, you are given y less than or equal to 7. I want to solve this. Y means 2x minus 6 less than or equal to 7. Y means 2x minus 6. So from this, 2x less than or equal to 7 minus 6, 13. From this, x less than or equal to 13 by 2. Yes, no, correct. Sujana, not correct. Please verify. So x less than or equal to 6.5. 0.3 correct. 0.3 is the right answer. Now, yes, 0.3 is the right answer. Look here, everyone. You are asked to find probability of y less than or equal to 7, x greater than or equal to 5 is equal to. This is A given B. A means this, B means this. Yes, 0.3 correct. P of A given B formula, P of A intersection B. P of y less than or equal to 7 intersection x greater than or equal to 5 divided by p of x greater than or equal to 5. So numerator y less than or equal to 7 is x less than or equal to 6.5. Intersection x greater than or equal to 5 by denominator x greater than or equal to 5. And look there, and everyone look here, this is 5, this is 6.5. X greater than or equal to 5 means this side. X greater than or equal to 5 means 5 to infinity. But at the same time, x less than or equal to 6.5. So x value bigger than 5, x value bigger than 5 and smaller than 6.5. Therefore, x should lie between 5 and 6.5. First of all, interval is minus 2 to 10. Note down the interval. Interval is minus 2 to 10. X value bigger than 5. X value bigger than 5 and smaller than 6.5. So x value lies between 5 and 6.5. X value numerator bigger than 5, smaller than 6.5. So x lies between 5 and 6.5. So what is the length of 5 and 6.5? Length of this interval is, probability of length of this interval is 6.5 minus 5 by length of the total interval is 10 minus of minus 10 plus 2 by denominator x greater than 5. Denominator x greater than 5 means what? 5 to 10. This is minus 2. Denominator is x greater than or equal to 5. X greater than or equal to 5 means this. So interval length is 5 to 10. Interval length 10 minus 5. Total interval length is 10 minus of minus 2, 10 plus 2. So this is 1.5 by 5. Answer 0.3. 0.3. Sixth question, and uniform distribution completed. Don't worry, at the end of the topic I will give you the definition of that is one simple definition only. Cumulative distribution function I will teach. Exponential distribution, it is a time related I'll complete probability and statistics today if you can cooperate. Time related probability distribution. Exponential distribution is purely based on time-related probability distribution. For example, a person standing at the queue to buy a ticket at the railway station railway counter. So how much time he has to wait to get his turn to purchase a ticket, or one person standing at the telephone booth, one person standing at the telephone booth in a queue, and how long he has to wait to get his turn to make a phone call at the telephone booth, or one person has made a phone call to the customer care. So therefore, how long he has to wait until his call is answered by the concerned customer care executive. So all these problems are related to exponential distribution. That means how long one person has to wait until the purpose of that particular person, what he is doing to be served. That is related to exponential distribution. It is purely time related probability distribution, especially it is waiting time of a person until one particular event occurs. Right down. Definition. A random variable capital X is said to have an exponential distribution if its probability density function is given by f of x is equal to lambda into e power minus lambda x, where x greater than or equal to 0. Actually, frankly saying, lambda e power minus lambda t, where t is the time is always greater than or equal to 0. Time always greater than or equal to 0 seconds. So x is the time and lambda means what? Where lambda is equal to distribution of amount of time until distribution of amount of time until some specific event occurs. So how long one person has to wait in the queue until he gets his turn to make a phone call at the telephone booth, or how long a person has to wait in the queue when he called to the customer care executive until his call should be answered by the concerned executive. So that is lambda. Note. Next slide. note write down first point mean. Mean of the normal distribution is 1 by lambda. Second point, variance 1 by lambda square. Standard deviation 1 by lambda. And remember the fourth one also, P of capital X less than or equal to small x. Capital X is the random variable, small x is the real number. Capital X is the random variable, small x is the real number. Capital X is the random variable, small x is the real number. We'll continue after the break, 10 minutes break. We'll continue after the break. After the break. independent exponentially distributed random variables with means 1 by lambda 1, 1 by lambda 2, 1 by lambda n. Fifth point continuation. Then it is a theorem statement. Fifth one is a theorem statement. Please do remember that. Then the distribution of x1 comma x2 comma xn is also an exponential is also an exponential distribution. It is a theorem statement. Please do remember that. With mean 1 by lambda 1 plus lambda 2 plus lambda 3 plus so on lambda n. Here, 1 minute. Here one small modification. Distribution of minimum of. Remember everyone, suppose x1 comma x2 comma xn are independent and exponentially distributed random variables. Each x1, mean of x1 is 1 by lambda 1, mean of x2 1 by lambda 2. Then the distribution of minimum of x1 comma x2 comma xn is also an exponential distribution with mean 1 by lambda 1 plus lambda 2 plus on lambda n. This is the theorem statement you need to remember. Moreover, you were asked distribution function definition. Please remember this statement. It is a theorem statement. And one definition we forgot at random variables. That is a distribution function. Also called cumulative distribution function. Cumulative distribution function, we can write it as CDF. Remember, cumulative distribution function is denoted by capital F of x. Throughout probability and statistics, small f of x is probability and probability density function. Capital F of x is cumulative distribution function. P of x is probability mass function. Cumulative distribution function also denoted by P of capital X less than or equal to small x. What is capital X? Here capital X is random variable. And small x is real number. If you want proof, I will give you, no issue. At the end of the session, I will give you. Please remember, note down. This is equal to probability of capital X less than or equal to small x means sum of the probabilities up to x is equal to 2. Up to x is equal to x. Sum of the probabilities up to capital X is equal to x. Here capital X where capital X is a discrete random variable. Continuous random variable probability cumulative distribution function is minus infinity to infinity f of x dx. Here capital X is a continuous random variable. Capital X is a continuous random variable. Do you know, if you here small f of x is probability density function. If you differentiate this with respect to x, you will get small f of x, which is the probability density function. So derivative of cumulative distribution function is also called probability density function. Because if you differentiate this last integral with respect to f of x, we get small f of, with respect to x, we get small f of x, that is probability density function. So derivative of cumulative distribution function is also called probability density function. Problems? If you want, you can write that. The derivative of cumulative distribution function is called probability density function. Next slide. Problem number 1. I don't let x1 and x2 be two independent exponentially distributed random variables with means 0.5 and 0.25 respectively. Then y is equal to minimum of x1 comma x2 is same problem, computer science engineering, and it was given like this. Instead of 0.5, they mentioned 1 by alpha. Instead of 0.25, instead of 0.5, they mentioned alpha. Instead of 0.25, they mentioned beta. Computer science engineering, it was earlier given in the gate. Exponentially distributed. With mean 1 by 6. Next, exponentially distributed with mean 2. Exponentially distributed with mean 3 by 4. Option A correct. It was given gate mechanical engineering 2018. Similar model problem was given in the gate computer science engineering. Instead of 0.5 and 0.25, they gave in the exam as alpha and beta. Option A correct. So the last statement only, if x1, x2, x3, xn are independent and exponentially distributed random variables, then the distribution of minimum of x1 comma x2 comma xn is also an exponential distribution with mean 1 by lambda 1 plus lambda 2 plus on lambda n. I will go to the next slide. Next slide. So mean of x1 was given. Mean of x1 is 0.5. Mean of the mean of the exponential distribution is 1 by lambda 1. That is 0.5. Also written as 1 by 2. So from this, lambda 1 is equal to 2. Next to mean of x2. Mean of x2, that is 1 by lambda 2. Mean of x2 0.25. Mean of x, not normal, sorry, mean of exponential distribution is 1 by lambda. Mean of x2 is 1 by lambda 2. That is 1 by 4. So 1 by lambda 2 is equal to 1 by 4. So that lambda 2 is equal to 4 then. Now the distribution of minimum of x1 comma x2 is also an exponential distribution with mean 1 by lambda 1 plus lambda 2, that is 1 by 2 plus 4, that is 1 by 6. In the same manner, you can try this. Let x1 comma x2 comma x3 comma x4 be independent exponential random variables with means 1 comma 1 by 2 comma 1 by 3 comma 1 by 4 respectively. Then y is equal to minimum of x1 comma x2 comma x3 comma x4 has an exponential distribution. Going to the next slide, has an exponential distribution. Next slide. With mean equal to dash. Every fill in the blank question in the exam exponential random variable different, independent exponential random variables different. There is no any relationship between two exponential random variables. Answer 1 by 10, 0.1. 1 by 10, 0.1. Try yourself. It is a fill in the blank question. Answer accordingly. Because every fill in the blank question is a numerical answer type. Write down the problem. If capital X is if capital X is exponentially distributed comma the probability that capital X exceeds its expected value is. You are asked to find the probability that capital X exceeding its expected value. So let us find probability of a random variable capital X exceeding means greater than expected value means E of X. Expected value means E of X. So this is equal to probability of capital X greater than E of X. E of X means mean of exponential distribution. Mean of exponential distribution is 1 by lambda. And all of you, please verify this slide. Property number 4, P of X greater than or equal to X or P of X greater than X is equal to e to the power of minus lambda X, e power minus lambda X, property number 4. So according to property number 4, P of X greater than small x, that is e to the power of minus lambda, X means 1 by lambda. I have used this property, property number 4, P of X greater than X is equal to e to the power of minus lambda X. So this lambda cancel. That would be e to the power of minus 1. After simplifying this, it should be 0.368. 368 or 367, no issue. 1 by E. Next slide. .3678 is the right answer. I have approximately written 0.368. Add on. Problem number 4. Suppose the average waiting time for a customer's call to be answered by a company representative is 5 minutes. The probability that a call is answered during the first minute is Remember, the average waiting time for customer calls to be answered by a company representative is 5 minutes. In the examination, they must clearly mention to solve one problem using exponential distribution. Don't worry regarding that. Even though actually it will be mentioned, don't worry. Otherwise, you can also remember exponential distribution problems are related to how much time or how long a customer has to wait until his purpose to be served. That means how long a customer has to wait until his call is answered by company representative. How long a person has to wait in the long queue to get he served. All that type of problems should be solved using exponential distribution only. How much time one has to wait until he get his turn. Until then the customer has to wait. All that type of problems related to exponential distribution. In this problem, average waiting time for the customer call to be answered by the company representative is 5 minutes. Average value of exponential distribution is 1 by lambda. Average value of exponential distribution is 1 by lambda. So 1 by lambda is equal to 5. So lambda is equal to 1 by 5. Moreover, and be careful what I am speaking. Probability that a call is answered by the company representative during the first minute. During the first minute means the moment the customer has called, then within 1 minute only his call should be answered by the company representative. Call should be answered during the first minute means the moment he calls, within 1 minute only, his call will be answered. So probability of customer call can be answered within 1 minute. P of x less than or equal to 1. I can also write it as 1 minus P of x greater than or equal to 1. And do you remember this formula I gave already? P of capital X greater than or equal to small x, or simply greater than or equal to greater than x, is e to the power of minus lambda x. Even we can prove this result also. Every result can be proved. 1 minus e to the power of x greater than or equal to small x. In place of small x, we have 1. So this is e power minus lambda into 1. So that is equal to 1 minus e power 1 by 5 means 0.2. 1 minus e to the power of minus 0.2. Tell me the answer now. 0.16, sorry, option A correct. 0.1813. 0.1813 is the right answer. Option A. Option A is the right answer. .1813. Write that. 0.1813. Previous slide, if you want, you can take screenshot and note this problem and try yourself. Next. Write down the length of the length of the shower means duration of rainfall. The length of the shower means duration of rainfall on a tropical island, on a tropical island during rainy season has an exponential distribution with parameter 2. Time being measured in minutes. What is the probability that a shower means rainfall. What is the probability that a shower will last more than 3 minutes? Try yourself. Answer 0.0025. Try later. And last topic, I am going to the last topic. Statistics. Heading statistics. So what do you mean by statistics? According to R.A. Fisher, he is called father of statistics. According to him, statistics is collection of data, analysis of data, and representation, interpretation of data. You need to collect the data, you need to analyze the data, and represent the data. This whole process is called statistics. So, collection of data means, suppose during this COVID, then they have to collect the data from different people. Suppose Hyderabad city is there, Then data is to be collected means people's they have to conduct the tests among all people of Hyderabad city, or randomly wherever the more cases are arising in the city, there they will have to conduct this COVID test, coronavirus test, and randomly they collect some samples from some particular areas only, because wherever the COVID cases are increasing, then they will have to conduct more tests there, and they will collect the samples from them in order to test whether they have COVID virus or not. That is called collection of data. After collecting the data, it should be analyzed. It should be analyzed means COVID test will be conducted and the results will come after 1 hour or 1 day. Then once the results are announced, then all those results will be arranged in a systematic order. So that entire process is called statistics, collecting the data, analyzing the data, and representing the data. Write down definition. According to R.A. Fisher, who is called father of statistics. Statistics is collection of data, analysis of data, and interpretation of data. So types of data. Raw data means collected data. You need to collect the data that is not analyzed numerically. Data should be collected that is not analyzed numerically. For example, the weights of the students of one particular college have been collected. According to the alphabetical listing of names, students' weights have been collected. But according to the weights of the students, it is not the proper way to collect the students' weights according to the alphabetical listings. It is the right way to represent the students' weights in the increasing order or in the decreasing order. Or you may consider heights of the students of a college, and collecting the students' heights according to the alphabetical listing of names is not a systematic way of representation. The systematic way of representation is writing the heights of the students in the increasing order or in the decreasing order. That is the right way of arranging the heights of the students. I mean systematic order. So raw data are collected data that have not been organized numerically. Example, heights of 100 male students obtained from an alphabetical listing of names or or listing of college records. Next slide. Arrays. Arrays means collected data should be arranged in a systematic order. Means students' heights will be arranged in a systematic order, or students' weights can be arranged in a systematic order. Write down arrays definition. An array is an arrangement of raw numerical data in ascending means increasing, or descending order of magnitude. So writing students' heights or weights in the increasing order or decreasing order. Remember, discrete frequency distribution means frequencies are distributed to separate x values like this. Frequencies are distributed. These are the frequencies. Frequencies are distributed to discrete x values, means separate x values. That is called discrete frequency distribution. Just frequencies are distributed to discrete x values, means each x values. A tabular arrangement of data by discrete values with the corresponding frequencies is called a discrete So now observe sum of the frequencies. Sum of the frequencies is 150, 10 plus 30 plus 50 plus 20 plus 40, 150. Its meaning is, practically we can assume like this. Its meaning is a coin is tossed 150 times. So one head occur 10 times, two heads occur 30 times, three heads occur 50 times, four heads occur 20 times, five heads occur 40 times. Practically we can convert like this. Next definition. Continuous frequency distribution. Write down. Continuous frequency distribution means x values are given like this: 0 to 10, 10 to 20, 20 to 30, here 4, 5, 7, like this. We can observe like this: 4 student marks lying between 0 and 10, 5 student marks lying between 10 and 20, 7 students marks lying between 20 and 30. That is the way we can represent. So frequency of student marks lying between 0 and 10, 4. Frequency of student marks lying between 10 and 20, 5. Frequency of student marks lying between 20 and 30, that is the way. We have just 2 topics or 3 topics only today. Uniform distribution, normal distribution we started yesterday itself. Uniform distribution, exponential distribution, statistics. Next, continuous frequency distribution. Write down. A tabular arrangement of data by classes together with the corresponding class frequencies is called a continuous frequency So X values will be given in the form of continuous classes 0 to 10, 10 to 20, 20 to 30, 30 to 40, so on. So a tabular arrangement of data by classes together. Classes together means 0 to 10, 10 to 20, 20 to 30, like that, with the corresponding class frequencies like 4, 5, 7, 12, 9. Next topic, heading. Listen to me. In binomial distribution, parameters are n and p. In Poisson distribution, parameter is lambda. In normal distribution, parameters are mu and sigma square. Exponential distribution, parameter is lambda, not 1 by lambda. Parameter is lambda. In any definition, in any binomial, Poisson, normal, exponential, other than x, any variable, any other new term is there, that is called parameter. Main heading, mean, median, mode. Very basics and fundamentals only, that you might have already studied. First definition, mean. Write down. For raw data like x1, comma, x2, comma, so on, xn. The mean is denoted by x bar, defined as average of sum of the quantities divided by total number of quantities. Sum of the quantities by total number of quantities, that is called mean. That is sigma I is equal to 1 to n xi by n. Next, for discrete frequency distribution, the mean is, remember, discrete frequency distribution means this. For a discrete frequency distribution, mean is 1 into 10 plus 2 into 30 plus 3 into 50 plus 4 into 20 plus 5 into 40 divided by 10 plus 30 plus 50 plus 20 plus 40. So the mean represented by x bar defined as x1 into f1 plus x2 into f2 plus xn into fn by f1 plus f2 plus f3 plus so on fn. That is equal to sigma I is equal to 1 to n xi fi by sigma I is equal to 1 to n fi. Next, for continuous basic definitions only that we studied in 12th class or 11th class or 10th standard. The mean is, remember, for continuous frequency distribution, mean is midpoint of x value into frequency, means 5 into 4 plus 15 into 5 plus 25 into 7 plus 35 into 12 plus 45 into 9. Midpoint of x into frequency plus midpoint of x into frequency plus midpoint of x into frequency, so on. Right, that mean is sigma I is equal to 1 to n xi fi by sigma I is equal to 1 to n fi. Where xi is equal to midpoint of ith class interval. Remember, this is x1 means midpoint of first class interval, x2 means midpoint of second class interval, x3 means midpoint of third class interval, xi means midpoint of ith class interval. That is the definition of mean. Definition median. So what do you mean by median? Right now, consider. So whenever you want to find the median, first of all, write all observations in the increasing order, or write all observations in the decreasing order. Look here, suppose all observations are written in the increasing order, then suppose the total number of observations are odd, 1, 2, 3, 4, 5. First to write the observations in the increasing order. Total number of observations are odd, exact middlemost observation is the median. Exact middlemost observation is the median. Suppose the total number of observations are even number of observations, 1, 2, 3, 4, 5, 6. Then average of middlemost two observations is called its median. I don't consider this set of observations arranged after this we do problems arranged in ascending or descending order of magnitude. Right now, if the number of observations are odd, if the number of observations are odd, then middlemost observation is called its median. Middlemost observation is called its median. Next slide. Example 1, 10, 25, 37, 92. 1, 2, 3, 4, 5. Total number of observations 5. So median is equal to exact middlemost observation. Median is the exact middlemost observation. If the number of observations if the number of observations is even, then the average of middlemost two observations is called its median. So 1, 2, 3, 4, 5, 6. 6 observations. 6 observations means total number of observations are even. Therefore, median is equal to average of middlemost two observations. Next slide. Now let us see for continuous frequency distribution. Next definition. For discrete frequency distribution, median is the value of x corresponding to the I will explain the second point meaning corresponding to the cumulative frequency which is just greater than n plus 1 by 2. Capital N is sum of the frequencies. You see this example. x. This is for discrete frequency distribution. X 11, 13, 17, 21, 25. So F value 13, 25, 11, 17, 21. So I will show you how to find the frequency. I'll write in the next slide. Next slide. Next slide. Write down. First of all, write x values. Next, write f values. Next, write CF, means cumulative frequency. So what are x values here? 11, 13, 17, 21, 25. Frequency is 13, 25, 11, 17, 21. Look here. Here first frequency as it is you write. Sum of first two, 13 plus 25, 38 will be written here. Sum of first three, 13 plus 25 plus 11 will be written here. These are cumulative frequencies. Sum of first four, 13 plus 25 plus 11 plus 17 will be written here. Sum of all these will be written here. Sum of all these frequencies will be written in the last column, that is 87. Capital N means sum of the frequencies. Everyone should remember capital N means sum of the frequencies. So therefore, look here. The last term in the cumulative frequencies column should be capital N only. The last term in the cumulative frequencies column should be capital N. That is sum of the frequencies value only. So first of all, find n plus 1 by 2. N plus 1 by 2, that is 87 plus 1, 88 by 2, that is 44. So first you need to identify what I said here. The x value corresponding to the cumulative frequency, which is just greater than n plus 1 by 2, just greater than n plus 1 by 2. Identify the cumulative frequency that is just greater than n plus 1 by 2. Cumulative frequency just greater than n plus 1 by 2. 13 not greater than n plus 1 by 2. 38 not greater than n plus 1 by 2. 49, 66, 87 all are greater than n plus 1 by 2. But we just need the cumulative frequency value just greater than n plus 1 by 2. Cumulative frequencies value just greater than n plus 1 by 2 is 49 you need to consider. What I said, x value corresponding to the cumulative frequency. X value corresponding to the cumulative frequency that is just greater than n plus 1 by 2 is called median. What I said the definition for median? Median is the x value 17 corresponding to the cumulative frequency that is just greater than n plus 1 by 2. Just greater than n plus 1 by 2. Next. Third one. Write down. For continuous frequency distribution, median is down L plus n by 2 minus m divided by f into c. This is the formula for median for continuous frequency distribution. I will tell you the notations. Next slide. L is equal to, here L is equal to lower limit. L is equal to lower limit of the L is equal to lower limit of the class interval. L is equal to lower limit of the class interval in the median class. I will tell you, don't worry. Here, you look the previous slide. What is the cumulative frequency that is just greater than n plus 1 by 2? Cumulative frequency just greater than n plus 1 by 2 is 49. That 49 occurring in this class. That 49 occurring in this class, right? So therefore, this class is called median class. This class is called median class. Also called ideal class. Generally, in case of continuous frequency distribution, we have 0 to 10, 10 to 20, 20 to 30. Intervals will be given. Here 20 to 30. Lower limit is 20. 20 to 30 here you have. So lower limit is 20. So L is the lower limit of the class interval in that median class. Next, do you know this is M? M means what? Here M is equal to 38. Look there. Here M is equal to 38. 13, 38. 38 is M. So M means what? It is the cumulative frequency value preceding the median class. Before the median class, we have 38. So M is 38. Before the median class, whatever you have, that is M. So right. M is equal to cumulative frequency value preceding. Preceding means before. Preceding the median class. Whatever the cumulative frequency existing before the median class, that is M. F means what? This is F. F is 11. F is 11. F is frequency value of the median class, 11 in this example. So F is equal to frequency of the median class. C is equal to size of the class. Size of the class means length of the class interval. Length of the class interval 0 to 10. Length of the class interval is 10 units. So C is equal to 10. Example. Write down. Find the median for the following frequency find the median for the following frequency distribution. Write down. Class N means sum of the frequencies. N means sum of the frequencies, you all know. Class here frequency 0 to 10, 4, 10 to 20, 20 to 30, 30 to 40, 50 to 60, 4, 5, 7, 10, 12, 8, 4. So whenever you want to find median, you need to construct one more column that is called cumulative frequencies column. Going to the next slide. Going to the next slide. So write down. Here class intervals. Here frequencies. And last column cumulative frequencies. Write down 0 to 10. 10 to 20, 20 to 30, 30 to 40, I have already given my mobile number in WhatsApp, in Telegram group also I am there. If you have any doubts, you can talk to me. You can WhatsApp. I'll give my numbers. I have already given yesterday itself. I gave. I have to complete this probability today, almost ending. Last topic this is. Cumulative frequencies. Sum first frequency 4 as it is. Sum of first two, 4 plus 5 will be 9. Sum of first three, 4 plus 5 plus 7. Sum of first four will be written here. Sum of all these will be written here. Sum of all these will be written here. Sum of all these will be written in the last column. That is 50. Sum of the frequencies is always equal to the last term in the cumulative frequencies column. The last term in the cumulative frequencies column is n. So find the value of n plus 1 by 2, that is 51 by 2. Answer 25.5. So identify the cumulative frequency. Identify the cumulative frequency that is just greater than 25.5. The cumulative frequency that is just greater than 25.5 is 26. Actually 26, 38, 46, 50 all are greater than 25.5 only. But we need to identify the cumulative frequency value that is just greater than 25.5. So that is 26 only. Now L means lower limit. This is ideal class. Identify the cumulative frequency that is just greater than n plus 1 by 2, that is 26. That is existing in which class? That class is called median class, also called ideal class. L means what? Lower limit of the class interval in the median class. 39 correct. 39 correct. L means lower limit of the class interval in the median class. F means frequency of the median class. M means cumulative frequency preceding the median class. M means cumulative frequency value preceding the median class. So median is equal to L plus n by 2 minus m divided by f into c. So L is equal to 30 plus n value 50 by 2 minus m 16, f 10, c means size of the class, also 10. This cancel. 2 25, 25 minus 6, 9, 9 plus 30, 39. You must have patience. We have one more topic. It may take 15 minutes time. One more topic that is lost. Last topic, heading, 15 minutes enough. Mode. 3 definitions for mode. Definition number 1 for raw data. Three, 4 times gate questions were given on this model. But basics only, it is there in the syllabus, we need to cover. That's why I'm teaching. Generally, least expectation in the gate. First topic, mode for raw data, mode for discrete frequency distribution, mode for continuous frequency distribution. Remember, mode means what? The event that occurs with the highest frequency. Means among all numbers, which number that repeated more frequently. Among all numbers, which number that repeated very frequently is called mode. Size of the class is 10. Write down. The event write like this. Mode is the event which occurs with the highest frequency. Among all numbers, whichever the number repeated very, very frequently, that is mode. Suppose no number is repeated very, very frequently, mode is not defined. Mode may be undefined. Mode may be undefined because among all numbers, whichever the number repeated very frequently, that is called mode. Suppose no number repeated very, very frequently, then mode is undefined. But mode is not unique. Two numbers are repeated very, very frequently. Two are called modes. Three numbers repeated very, very frequently. Three are called modes. So, mode is not unique. It can be bimodal. Bimodal means two numbers repeated very, very frequently. Trimodal means three numbers repeated very, very frequently. Example, completed 5-10 minutes. 27, 35, 40, 35, 36, 36, 29. So among all numbers, which numbers repeated very, very frequently? 35 and 36 repeated very, very frequently. Therefore, 35 and 36 are called 35 and 36 are called modes. Mode of 1, 1, 1, 1, 1 is mode. Among all numbers, whatever the number that repeated with highest frequency, that is called mode. No number repeated frequently, mode 0. Two numbers repeated frequently, mode, those two numbers are modes. Next, second, for just 5 to 10 minutes for discrete frequency distribution. For a discrete frequency distribution, mode is the value of x. Mode is the value of x corresponding to highest frequency. Mode is the value of x corresponding to highest frequency. For example, x value 11, 13, 17, 21, 25. The frequencies are 13, 25, 11, 17, 21. Among all values, which is the highest value of x? Highest frequency. Highest frequency is 25. So x value corresponding to highest frequency is called mode. So mode is the value of x corresponding to highest frequency. X value corresponding to highest frequency is called mode. Last. For continuous, last topic, for continuous frequency distribution. For continuous frequency distribution, note down. Write down first. Mode is equal to L plus delta 1 by delta 1 plus delta 2 into C. Write down. Where, sorry, delta 1 is equal to f minus f suffix minus 1. Delta 2 is equal to f minus f suffix 1. So f is equal to frequency of the modal class. Remember, modal class means highest frequency. Highest frequency class is called modal class. Here highest frequency is 1325. So 1325 is called modal class. Just 5 minutes completed. And f suffix minus 1 is equal to frequency whatever the frequency existing before the modal class preceding the modal class. X1 is equal to, sorry, F1 is equal to F suffix minus 1, that is frequency succeeding. Frequency succeeding means after whatever the frequency which is existing after the modal class. L is equal to lower limit of the class interval in the model class, C is equal to size of the class. Do this problem and try yourself. Find the mode of the following frequency distribution. Find the mode of the following I don't just 5 minutes class zero to 10, or I will write directly question and answer. Class 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. This is 4, 5. 4, 5, 7, 10. 4, 5, 7, 10, 12, 8, 4. If the highest frequency is in the first class, then if the highest frequency existing here, before the highest frequency, if you don't have any problem, then it should be 0. Highest frequency existing in the last class, then f suffix 1 is frequency after the succeeding class. We don't have, then it should be taken as 0. It should be taken as 0. Completed. First, listen to me. Here you need to enter highest frequency. You need to enter highest frequency is 12. That is existing in this column. Therefore, in this class. Therefore, this class is called model class. Or highest frequency class is model class. L means lower limit of the class interval. F means frequency of the model class. Answer 43.33 is correct. If two model classes are there, suppose the highest frequency is 12. If 12 exists at two places, take anyone as model class. But generally in the examination, it will not be given like that. F suffix minus 1 means frequency before the modal class. F suffix plus 1 means frequency after the modal class. Now find delta 1. Delta 1 is F minus F suffix minus 1. That is 12 minus 2. 12 minus 10, that is 2. So find delta 2. That is F minus F suffix 1. 12 minus 8. That is 4. So I will write in the next slide. So mode is equal to L plus delta 1 by delta 1 plus delta 2 into C. L value 40. Delta 1, 2. 2 by 2 plus 4. Size of the class is 10. So answer 43.33, I think. 43.33. And listen to me, everyone. Please remember, completed, syllabus completed, just relationship between mean, mode, median is mode is equal to 3 median. Relationship between mean, mode, median is mode is equal to 3 times of median. Mode is equal to 3 times of median minus 2 times of mean. Completed, just 2 minutes. I will show you all slides, whatever you want. But wait for 2 minutes. And one more. Write down for symmetrical curve. Remember, for all symmetrical curves, this is a symmetrical curve. Completed, just 2 minutes only. I will talk to you symmetrical curve. Everyone should remember that for all symmetrical curves, when you calculate mean, median, mode, all are identical. Symmetrical curve means same shape of the curve will exist on both sides of this vertical line. Normal distribution curve is a symmetrical curve. So, normal distribution curve, mean, median, mode same. This is a left skewed curve. Left skewed curve means it is not symmetrical. This is a left skewed curve. Left skewed curve means left side the curve will have long tail as compared to right side. Left side the curve will have long tail as compared to right side. So for left skewed curve, mean less than, median less than, mode. For right skewed curve, mean greater than, median greater than, mode. This is left skewed. Left skewed means curve has a longer tail on the left side as compared to the right side. Similarly, right skewed curve. Right skewed curve means curve has a longer tail on the right side. Curve has a longer tail on the right side. It is a right skewed curve. For right skewed curve, mean greater than, median greater than, mode. Mean greater than, median greater than, mode. 99%. This mean, mode, median topic will not be given in the examination. It is there in the syllabus. That's why I have taught. If you want, you can prepare up to prepare. If you want, you can prepare up to exponential distribution. That is fine. Remain the statistics. If you want, you can skip for exam, or if you can briefly review. No issue. You can talk to me now. I'll clarify your doubt. Syllabus completed. Yesterday I gave my mobile number, and in WhatsApp I can share some questions for your practice purpose. In WhatsApp I can share some questions for your practice purpose. If you have any doubts, you can talk to me right now. Raise your hands. See, my humble request to everybody, preparation strategy, prepare each and every topic. One, now probability and statistics completed. So probability and statistics, first of all, please maintain a short notes. Means from each and every topic, whatever the points that you need to highlight or you need to remember, maintaining a separate short notes. And frequently preparing, and when you are preparing first time only, you can go through your notes thoroughly and practice the classroom notebook problems thoroughly, and last 25 years gate questions also perfectly have to practice. After that, maintain a short notes. Second time you can go through the topics of short notes only, and class notes just briefly review. Each and everything you should not prepare. And before the examination, you just review only short notes. Notes should not be prepared. Last 25 years gate solutions and volume and whatever I taught in the classroom, and short notes, and frequently writing online or offline based exams, it will boost up your confidence. Still, if you have queries, then you can discuss in non-technical group or computer science. Anshul? Anshul?
Sir, actually, can you hear me?
Tell me.
Sir, actually, I don't have doubt, but after base theorem, the first problem what I have noted, I haven't noted properly. Could you show me that once?
Slide number?
I don't know the slide number, sir. I know only that after
Which
base
topic?
base theorem.
Huh?
Base theorem.
Okay, 1 minute. After Bayes theorem?
First problem, sir, after base theorem. You told us to make some changes. I haven't made properly, so I'm not.
This one, huh?
After that, this problem only, sir. Wait, I'll take
This one, huh?
Yes, this one and the.
See, students, if you want, I can give you the PDF form of the notes also.
We'll give that one also, sir.
Next slide, huh?
Okay, next slide.
Next slide.
Yes, sir. Next slide.
Ah,
Another one, sir. Please.
ah.
Next call.
Okay, na?
Yes, sir. Enough.
Okay, na?
Sir, could you please wait for 1 minute? I'll see if there is any other thing I need to take.
No, no. Actually, okay, you can take. I can wait. Other students are waiting. That's why I'm asking.
Okay, sir. I will unmute. I will mute if they will also talk. I will raise the hand once again if there is any other thing, sir.
Okay, check it and first mute yourself and again raise the doubt. Next, Anup. Anup. Anup.
Hello, good afternoon, sir.
Good afternoon. Tell me.
I have a doubt. I have a doubt in binomial distribution, sir. One homework question came. A certain type of missiles hits the target with probability 0.3, the minimum number of missiles. Yes, sir.
This problem,
Yes, sir.
I will give the hint and then solve. Otherwise, you can WhatsApp me. I will send probability of a missile hitting the target is 0.3, right?
Yes, sir.
And Q is equal to 0.7.
Yes, sir.
N value not given. We need to find how many missiles are to be fired. N value don't know, right?
Yes, sir.
So the minimum number of missiles that should be fired so that probability of hitting the target at least once. At least once means what? Greater than or equal to once. Probability X means hitting the target by the missile. Probability of hitting the target at least once is
Greater
than 75% means 0.75. P of X greater than or equal to 1 means what? 1 minus
P of X,
less than 1. Less than 1 means what? 0 only.
Yes, sir.
Greater than 0.75. So 1 minus P of X is equal to 0. If you substitute X is equal to 0 in the binomial distribution, you will get only Q power N. That is greater than 0.75. Now 0.75 will go left side. 1 minus 0.75 greater than Q power N. This is 0.25 greater than what is Q? 0.7 whole power N. One possibility is take logarithms both sides and then find N value. Other possibility is error and trial method. Take N is equal to 1 and verify this condition is satisfied or not. Not satisfied, verify with N is equal to 2. It will not satisfy for N is equal to 1, 2, 3. It will satisfy for N is equal to 4, 5, 6, 7. So minimum means smallest N value is 4. Okay, na?
Okay, sir. Thank you, sir.
Next, Sahiti. Sahiti.
So, am I audible?
Yes, it's audible. Tell me.
Good afternoon, sir.
Good afternoon.
Yesterday you gave one sum for homework. A plus bx, f of x equals to a plus bx. The density function of a random variable x is given by f of x equals to a plus bx.
Yes, yes. Tell me.
So for that e of x square.
This one. Right?
Yes, sir. Yes, sir. E of x square can be taken as x minus mu whole square into f of x.
1 minute. E of x square of variance of x, you are saying.
E of x square, sir.
E of x is integral x f of x. E of x square is integral x square f of x. Variance of x is integral x minus mu whole square f of x. Because variance is, I said sigma x minus mu whole square into p of x, integral x minus mu whole square into p of x.
Okay, sir. Then this e of x square is x square into f of x dx, sir.
Yes, e of x means x integral x f of x. E of x square is x square f of x. E of x cube is x cube f of x.
Okay, sir. Thank you, sir. Sir, and one minute, so I didn't get a sum.
Tell me.
Sir, a telephone exchange receives an average 180 calls per hour. Sir, I'm getting that 0.112, sir. You said answer is 0.224.
Telephone exchange. Okay. Today's expert last model R.
Yes, sir. No, sir. Yesterday's Poisson's distribution, fourth sum.
A telephone exchange receives an average of 180 calls per hour. 180 calls per hour means 60 minutes, 180 calls. Then we want the information per 1 minute only. Then 1 minute is 1 minute is 1 by 60. 1 by 60 into 180. That is lambda value. Did you get 3?
3. Yes, sir.
A lambda value 3, correct? After that, you need to find P of x is equal to 2. That is lambda power 2 into e power minus lambda by 2. That is 9 into e power minus 3 by 2. This one only have solved?
Yes, sir. I did calculation wrong. Sorry, sir.
Please verify.
Yes. Okay. Sir, and today's first sum, fourth sum.
Tell me.
So I came late, sir. Can you just explain me this sum?
They have already said x is a random variable with mean. X is random variable with mean 1 and variance 4. Sigma square is 4. Yes. Y is another normal random variable with mean minus 1, variance not known.
Okay, sir.
And P of x less than or equal to minus 1, then P of y greater than or equal to 2, then find the variance of y, means standard deviation of y.
Yes.
And look there, any random variable is converted to standard normal random variable. Make x as x minus mu by sigma.
X minus mu.
This is z less than or equal to minus 1, z greater than or equal to. This is the formula. Actually, I proved here. P of z less than or equal to minus z naught is equal to P of z greater than or equal to z1, then z naught is equal to z1. I proved. Here the formula you observe. Prove.
So it's minus z naught.
Which one? Last step?
Last step, so minus.
Listen to me. 1 minute. Normal distribution curve is a symmetrical curve. Area between interval length same, area same. Whatever the interval length between minus z naught and 0, same interval length will be there between 0 and z naught, no? That's why minus z naught less than z less than 0 is written as 0 less than z less than z naught.
Okay.
That's it, huh?
Yes, sir, that's it. Thank you, sir.
Fine. Prashant?
Good afternoon, sir. Good afternoon.
Tell me.
Sir, for the same sum.
Understood. Tell me.
So for the same sum, like P of x less than or equal to minus 1 is equal to P of y greater than or equal to 2 is the given, sir. So why even this can be taken as in the normal distribution curve? Because rather than converting the standard distribution curve,
they said x and y are normal random variables, no?
Yes. So instead of converting to set, is it because the area?
Okay. If you want area, I understood what you are saying. 1 minute. So this is normal distribution graph. This is minus 1. If you know the area from minus infinity to minus 1, directly you write. And one more is P of y greater than or equal to 2. Y greater than or equal to 2 means another graph.
So
y greater than both. If you want, you can equate.
Here we draw the different graph. Here in terms of x and y.
Any random variable, either x or y or z or anything, any random variable that is subtracted from mean and divided by standard deviation, that becomes one type of standard normal curve only. Standard normal curve. Original normal distribution different, standard normal distribution different. So any random variable is converted to single standard normal distribution only.
So in terms of x, y,
See,
or z,
suppose
each.
look here, x
Okay.
plus y, right?
Okay.
Sum of two random variables. Then it will be a new. If x and y are independent random variables, then x plus y is also a random variable. That is new random variable z.
Okay,
And
sir.
doubt is what?
So say if any x or y or z have a different graph. So if it is converted to standard, all these random variables would have a common graph. Is it like that?
Yes, all graphs will have standard. Otherwise, how can we equate this? You are saying that sir, x different, y different. We should draw two different graphs for them, right?
So I'm asking, we are drawing for standard deviation the same graph, then y, x and y also can be drawn in the same graph instead of converting to a standard normal random variable. Instead of drawing, sorry, instead of yes.
Different graphs. Huh?
So
You are saying that to different. They are saying, see, look here. They are saying both are equal. No, x minus mu by sigma, or y minus mu by sigma, same z only. No. You
yes,
are
sir,
saying
same
that
z.
sir, x minus mu by sigma one z and y minus mu by sigma another z graph.
Yes, yes, sir. Okay.
No. Both must have same z graph only.
Okay, sir. So can you go to the next slide? The graph, where the graph is there. Yeah. Here instead of minus z, we can put the, assume that this is a normal distribution curve. Instead of like minus z, we can put minus 1, and instead of z1 it's 2. So the area is equal, which is given.
Actually, this is normal. This is normal. This is standard normal. Normal different, standard normal different. No.
But in the question they have given that both the areas are equal. So can that run be in the same graph?
No. Both. See, both areas. So in the process of conversion, z will be minus 1 and z not different. No. How x will be taken as directly z? If it is x minus mu by sigma, no. How can you take z less than or equal to minus 1 is equal to z greater than or equal to 2? In the process of conversion, this right side variable is different. No.
Okay, sir.
See, 1 minute. If you have a doubt, actually the problem, listen to me. X less than or equal to minus 1. X less than minus 1 means what? Integral minus infinity to minus 1.
Okay, sir.
F of x dx. In the process of conversion, later it will take different value. 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu by sigma whole square dx. Here you need to assume x minus mu by sigma is equal to z, no?
Yes, sir.
Then you will get a different graph, limits will be different, and function will change, you will get new integral. No, how both must be same?
Okay, so in terms of y also taking, is it like we have a different, because in that case we are converting both as z, the limits are different, but we are putting in the same graph. But in terms of x and y, we are putting in different graphs. That's what I have doubt.
Understood. Clear, what you are asking is correct. I'll confirm and let you know. Okay, na?
Oh, okay.
Any other?
So one more thing, in the same sum, the z value is less than 1 by 2. Is it not 1 by 2? Sir? In the same sum.
In the same sum, yes, you have to. In the same sum, tell me.
Mu is.
Tell me.
So it's minus 1 and the mu is 1, sir. So it's minus 2 by 4, right? In case, in the next slide. So it's minus, the sigma is 4. Okay, okay, variance is, yeah, okay, sir, no problem. That one is.
Okay.
Sigma.
That I'll confirm and let you know tomorrow. Okay, na?
Okay, sir.
That is genuine doubt only. I'll confirm. I'll confirm tomorrow.
Because is my question is like valid or?
No, valid only. Fine.
Okay, sir.
Okay, na?
Okay, and next sum, the real root sum given a quadratic equation.
Tell me, because other students are also waiting. Tell me.
Here we are considering y as a constant. That means b is equal to.
Yes. Why? Here the quadratic expression I have considered. Actually, they said random variable is y, so we need the quadratic expression in terms of y. Probability of the quadratic expression will have real roots. So that b square minus 4ac should be in terms of y. Correct or not? Because y is the random variable.
Yes. So based on the question, we have decided b is equal to, so there is no other standard.
Y is the random variable. That's why that b square minus 4ac should be in terms of y.
Okay, sir. Okay, sir.
That's it, huh?
Yes, sir. And identifying uniform distribution, you told like with the intervals we could identify.
Generally, they mentioned one point is chosen at random from a circle. What does it mean?
Within a circle, yes.
It can be chosen from any point, anywhere inside the circle. Yes. Uniform or not?
Yeah, uniform in the sense.
See, any point can be chosen. See, there are infinite number of points. All have the same chance of selection, no?
Yes, sir.
Then it is uniform.
Okay, the probability is the same.
But in the exam, they will mention.
Okay, sir.
Next.
Okay, sir. Thank you, sir. That's it.
Is it clear what I said?
Yes, sir.
Okay.
Thank you, sir.
Okay. Rahul.
Hello, sir.
Rahul. Tell me.
So the last sum before the exponential distribution. In that.
Last sum before the exponential, huh?
Yes, sir.
This one, huh?
Yeah, this one, sir.
Tell me.
In this question, he is given that x is greater than 7, no, sir. So why we taken y less than or equal to 7?
No. Yeah, in the question, what they give, tell me.
Okay, I wrote it question mistakenly, sir. Okay.
Okay, na?
Okay, sir. It's clear now.
Tell me, Mareshwaram, can you hear? Do you hear me? Mareshwaram, do you hear me? Mareshwaram, do you hear me? Okay, I'm going to end the session.
So one more doubt.
Tell me. I have, because afternoon class is there.
After this 7 car accidents can occur in a week. In that second question, sir, no 2 accidents occur in the same day of a week.
Second one only you want?
Yeah, second one only, sir.
First accident can occur on any. No 2 accidents means any 2 accidents should not occur on the same day. That means one accident one day only. First accident can occur on any one of 7 days. Then second accident can occur on any one of remaining 6 days only. Because one day one accident. Any 2 should not occur on the same day. That means one day one accident. So one accident can occur. For one accident, there are 7 choices to occur on any one of 7 days. Correct?
Yes, sir. Yes, sir.
Then second accident can occur on any one of 6 days only, no?
Yes, sir.
Third accident can occur any one of 5 days. Next, any one of 4 days. Next, any one of 3 days. Next, any one of 2 days. Next, any one of 1 day. That is 7 factorial by 7 power 7. Is it clear?
Sir,
not clear.
Like, yes, sorry, is it no 2 accidents means it is not like it's no more than 2 and
no, not more than 2, not less than 2. No 2 accidents. Any 2 accidents should not occur on the same day.
Okay, sir.
No 2 accidents means not more than 2, not less than 2.
Okay, only 2 accidents.
2 accidents should not occur on the same day. The sentence meaning is.
So 3 can occur. So
if 2 cannot occur, how 3 can occur? 3 are occurring means 2 more than 2 occurring, no?
Okay, sir. So can you explain one more time to this one, the 7 factorial, that one?
See, 2 cannot occur on the same day means you are saying 3 can occur on the same day. 3 occurring on the same day means 2 already occurred no on the same day. More than 2 occurring no.
Okay, but they given no 2 accidents. So is it like exactly no 2 accidents should occur, or 2 or more shouldn't occur? So that's
any 2 accidents should not occur on the same day. Okay. Means any 3. If 2 cannot occur, how 3 accidents can occur on the same day?
Okay, so it is like only 1 can occur on 1 day.
1 can occur on 1 day. If 2 cannot occur on the same day, then how 3 can occur on the same day?
Okay, sir. So only 1 should occur on each day.
Probability, that is a little bit sentence confusing only. Any two accidents should not occur on the same day means how if 2 cannot occur, how 3 can occur?
Okay, sir.
If 3 are occurring means 2 are occurring, no more than 2 occurring. Then the question should have been probability of more than 2 accidents should occur on the same day.
Okay, sir.
Then problem will change like this. It should be asked like that in that case. Is it clear or a little bit confusing?
Yeah, it's clear, sir. So can you explain how to solve that? Because you told 7 factorial. Yeah.
So one day, one accident, correct?
Yes, sir. One day, one accident.
Then
yes,
first
sir.
accident, you take one accident. That is the first. There are 7 choices. No, that first accident can occur. It can occur on Monday or Tuesday or Wednesday or Thursday.
Any of the day. Yes, any of the day. 7 chances.
Then 7 choices. Then we are left with 6 choices only. No, for the next accident.
Yeah, next accident. Yes, 6. Yeah, we have 6 choices.
Next to 5 choices.
5 choices. Yes. Yes, sir. Okay, it's 7 factorial. Yeah.
Okay, na?
Yes, sir.
Okay.
So in one more thing, how we would solve if it is only exactly no two accidents should not?
Exactly. You find the probability of exactly 2 accidents can occur. Then 1 minus.
Okay, sir.
Okay, na?
Okay, sir. Yeah. Okay, sir.
Fine.
Yeah, thank you, sir.
Sai Mohan.
Hello.
Tell me.
Good afternoon, sir.
Good afternoon.
Sir, you said that you shared the probability notes, sir. When will you share? I already sent one message to WhatsApp.
Now you send me to the WhatsApp group. I have class in the afternoon. By the end of the day today.
Sir, you send me that file, sir. We are already in the Telegram room. I will send it in the group, sir.
I can send in group in PDF format. I will send. Okay.
Okay, sir. Send me. I will send it in the group, sir.
Fine.
Okay.
Students, I am going to end the meeting.
Sir, only one thing, sir. I am Anshul Kumar. I already talked to you.
Tell me, because I have class in the afternoon. Tell me.
I understood. Could you please explain this problem? What will a certain type of missile hits the target with probability 0.3, something like that? One problem is there, no, sir. I actually whether I have written the question wrong or not, I don't know, but I'm not able to solve problem, sir.
1 minute. This one,
Yes, sir.
check. Find n value from this answer.
Yes, sir. Actually, I haven't written at least, so I'm getting the wrong answer. Okay, sir. I think I'll get the right answer.
Now, okay, na?
Okay, sir. Fine. Another thing, sir. What is the Telegram channel group name, sir? I think I am not in there.
Ask one of your friend. There is Telegram channel is there. Computer science.
Sir, I don't have any friends, sir, because this is online class, so I don't have any friends who are in this.
You send me WhatsApp group. I will send the link. Okay, na?
Okay, sir.
Sir?
Tell me, Amma.
So, you gave one homework, some consider two identical bags B1 and B2, each containing 10 balls. So, I'm directly getting the answer as 7C1 by 10C1. Is it that direct or did I do anything wrong?
No. That is wrong. I will send the solution because what is the question? 1 minute.
Before random variables, before random variables. Yes, sir. This 7C1 by 10C1.
No. First, you need to select one bag, and then after selecting the bag, then you need to choose a ball.
Yes, sir.
Then selecting bag 1. You select a bag. It should be B1 or B2.
Okay.
And then from B1, choose red.
Okay.
That is 7C1 by
7C1 by 10C1.
Next 10C1. Next choose bag 2 and then choose red ball from that.
3C1 by 10C1.
That's it. Add all this. You will get a probability of red ball.
Okay.
After that, you need to. Is it clear?
Yes, sir. Yes, sir.
Okay, na?
Yes, sir.
Fine. Still, you have any doubts? You can send in WhatsApp group or I'll share that.
Yes, sir. Thank you, sir.
Fine.